a meaningful name. And you'll see this, excuse me, and you'll see this coming back at different levels of abstraction. Grouping things and naming things, really important. But still, if you only have like instructions and methods, it's quite hard to really develop large-scale software. So that's why somewhere in the 90s, even a little bit before that, object orientation came along and gave us classes to actually group methods in a class with data and to give it a meaningful name again. So again, we're grouping, but at a higher level, we're now grouping methods, and we can give it a name. But crucially, there's a third mechanism at work here when we're doing object-oriented development, and that's adding access control at this level. So what we can do with a class, at least in Java and many other languages, is we can indicate whether a method is private or public, right? So we can hide internal implementation details, and we can actually expose public functions that are the API of the class. And this really helps us to scale development as well, because as we all know, if you expose everything to everyone, it quickly becomes very complex. And in this case, we can pick and choose what is public API to be consumed by other classes and what is private through this access control mechanism. So we have three mechanisms that work: grouping, naming, access control. Now, it doesn't end there, for Java at least, because we also have this notion of packages, where again, we're grouping related classes and types into a single package with a given name. And at that level as well, we can do access control, right? Because we can have package private types and we can have public types that are usable from other packages. Now, hopefully you can feel this coming, but modules actually do the same, but at an even higher level of abstraction. So modules group related packages. You can give a module a meaningful name. And a module also does access control at this higher level, exposing certain packages to the outside world and encapsulating other packages as private implementation details. Now, this is sort of the intuitive feeling that you should have when thinking about modules. It's a tool to do large-scale development and to structure your code base in such a way that it becomes feasible to do development on complex and large systems. Now, what does this mean in terms of Java features? So when we look at modules in Java, actually you should think as modules as just jar files, but with some additional information. And this additional information lives in a module declaration. And a module declaration lives in module.info.java, as you can see here. This is the simplest possible module declaration, where you have a module keyword, the name of the module, which is main in this case, and like we saw before, a module groups packages. So at runtime, there's also still this notion of a module with the name main. This means that this module info.java also gets compiled into a class file, which is available at runtime to the JVM as well. And it groups these packages. So here we have our first and simplest possible module. Now, if you're doing modular development and modular software architecture, and you only have one module, you're doing it wrong, right? Because modular development means that you're going to split up your application into separate modules that each have their own piece of independent or semi-independent functionality. And somehow you need to bring these modules together into a working application. So fortunately, the module system also helps us with that. So besides being able to group things, name things, and to do access control, it's also about having explicit dependencies between these modules. And as you can see, we introduced a second module here called helper, again with a module declaration in module info.java. And we can see that module main uses code that lives in module helper. And we can express this using requires. And requires, this information is part of the module declaration that's both there at compile time and at runtime. So what happens is that if we have these two modules and we will start our application, that the module system can actually verify whether, if you're starting this main module, whether the helper module is there. And if it's not there, it can tell us that we should fix that before it even loads a single line of code of our application. And if you think about it, that's quite a difference with our current class path situation, right? Because I think we've all been there, where you had some class path and you start your application, and at some point you get like a class not found exception because, well, maybe you forgot a jar file, you had the wrong version of a jar file or whatever. All these things are just because jar files are done, right? Even though there are dependencies between jar files, it's not expressed in this jar file itself. So we just put them on the class path and hope for the best. And mostly because we have great tooling around the ecosystem, even Gradle, etc., to help us with that. Most of the times it's okay, but lots of times we still run into class path issues. So modules with their explicit dependencies help with that. Now, as we discussed, modules aren't just about grouping and access control, but also about being able to define a public API at the module level. And we do this using the exports keyword. So exports takes a package name as its argument. And as you can see here, we have an helper.api package containing types that should be consumed and used by other modules. By saying exports helper.api, we signal that these are the types that other modules can actually use if they have a dependency on this helper module. On the flip side, this means that any other packages that are inside of this module where there's no export statement are strongly encapsulated. And strong encapsulation in this case means real strong encapsulation. So we're not able to program to any types that are in this package. So whatever is in this helper.impl package can only be used inside of the helper module. And what's more, we're all pretty used to the fact that we're able to work around all these access controls with reflection, right? Usually. That's also not possible with encapsulated packages. So this is real strong encapsulation going on at every level, at the compiler, at the JVM, etc. Now, of course, there are some situations where this strong encapsulation is a little bit too strong because we're currently using lots of frameworks that use reflection, like Spring, Hibernate, and all these kinds of frameworks, they rely on reflection. Now, whether that's a good thing or bad thing, I'll just leave that as an interesting discussion for in the breaks. But that's just the fact of life. Now, what would happen if your service implementation class would live in this helper.impl package and your service interface would live in the helper.api package? Things would break because Spring wouldn't be able to reflectively instantiate your implementation class because, well, it's strongly encapsulated. So for these cases, we have a open package concept. And open packages are packages that at runtime allow reflective instantiation of whatever is inside of this package, but at compile time still prevent you from coding to these implementation classes. So this is sort of a perfect middle ground for these situations where you're using frameworks that need runtime access to types, but you want to limit yourself at compile time to code to interfaces rather than to implementations. So these are the basic concepts of modules and module declarations. Now, just to illustrate how this works in practice, I want to give you a small demo application. I want to show you how this works at the Java language level. So what I'm going to show you is a small application called EasyText. And the goal of EasyText is to just read in a piece of plain text and to analyze this text with a certain standard text analysis algorithm, and then give back the complexity metric for this text. And we're going to build this application as a two-module application. The first being EasyText.cli, our command line interface module, and the second one being EasyText Analysis, which contains the actual analysis logic. And we're going to do this using plain Java and modules. So let's see what this looks like. So here I have a simple text editor, Atom. I'm not using an IDE. That's not because IDEs don't support modules, they do, but because I want to show what's really changed, and I don't want the IDE to hide this in the background for us. So here we're just having a bare bones Java application with a source folder, and in this source folder you can see two module source directories. And how can I see that it's a module source directory? Well, there's the name of the module, then there's this module declaration that we talked about, and there's some code in a package, in this case just a plain main class. The module info.java, as you can see, is currently pretty empty. It's just the module keyword and the name of the module. By the way, this module keyword is only a keyword in the context of module info.java. So if you have any source code lying around using module as an identifier, that fortunately still compiles. So that's not an issue. And if we look at the second module here, then you'll see that it's equally empty currently. It's just module keyword and the name of the second module. Looking at the code, just to give you some context, this is the plain Java class with a main method. We're just reading in a file, then we chop up the file into sentences and words, And then we instantiate this flash Kincaid class, which contains the analysis algorithm, and we call analyze on it. And this flash Kincaid class lives in the different module, in the analysis module. So if we look at that class, again, it's just a plain Java class, no frameworks, no annotations, nothing. And it has an analyze method. We won't go into all the details, but this gives back a complexity metric for the text. Now what I want to do is I want to compile this, and for that I'm going to use the Java compiler directly from the command line, and I'm using a new flag called module source path. And this flag understands the layout that we have here of having a source folder with multiple modules to compile. Then I'm setting the output directory, and this is something that we often forget, but if you use the Java compiler directly, then you will have to provide all source files to the compiler that it needs to compile. So I'm using this little find trick to gather all 4 Java files, the flash Kincaid, module info, main, and the other module info, to actually compile this. And if we do it like this, an interesting thing happens. Because even though everything's there, everything's in place, we do get a compile time error. And it says, package Java modularity EasyText analysis is declared in module EasyText analysis, but module EasyText CLI does not read it. And does not read it means there's no dependency from EasyText CLI to EasyText analysis. And that's right, because we have this empty module declaration. So what we can do is we can add requires EasyText.analysis to make explicit that this relation exists. And you might be thinking, okay, well, in the real world, my IDE might do this for me, right? Just like auto imports, you could have auto requires. And that's somewhat true, but I would caution against that, because adding a dependency to your module, so actually expressing that your module needs another module, is really an architectural or a design decision that should be made deliberately. Do I actually want this relation to exist? That's the question that you should always answer before adding a requires to a module descriptor. But in this case, yes, this is really what we want. So let's do that. And we're going to compile again. There we go. And interestingly, we still get an error. It sort of looks the same, but it's not. It's slightly different. It's still talking about the same analysis package, which is in module EasyText analysis. Yes, that's right. But it says, which does not export it. And this is the strong encapsulation that we talked about in action. So because we, as module developers, decided not to export this package, other modules are not able to use code inside of this package. So it's strongly encapsulated. In this case, we do want to expose it for this demo. So let's say that we say exports and then the name of the package that we want to export from this module, EasyText.analysis. There we go. And now, if we compile again, we finally get a successful compilation. And in our out directory, you actually see the same 2 module directories, but now they're compiled. And as you can see, this module declaration is also still there in compiled form. And what we can do now is we now can run this application as a modular Java application. And for that, we're just going to use the Java runtime, of course. And instead of using the class path, I'm going to use the module path, which understands having multiple modules in a directory. And instead of just starting an arbitrary class file or jar file using -jar, I'm using the new -m flag for starting a module. And I'm going to say I want to start EasyText.cli. And well, because I haven't packaged this into a jar file yet, and it doesn't have a main entry point configured yet, I also need to be explicit about which class I want to start, which is Java modularity EasyText.cli.main, as you can see. And now we actually finally execute our application. It says, okay, please provide a file name. Let's do that. Test input. And we get back a flash Kincaid score of 83. So I'll leave it as an exercise to the listener to see whether that's actually complex or not. Wikipedia is your friend. But we now have a working modular application. So I hear some of you thinking, well, module path, class path, what's in the name? Looks the same to me. And the best way to illustrate this is by, in this case, making sure that we have an invalid module path. So I'm going to delete this analysis module, right? And I'm going to, of course, not recompile again because that would be cheating, but I'm going to run the application again, the same way I did before. And as you can see, it now says, okay, module EasyText analysis not found, and it's required by EasyText.cli. This is so much nicer, of course, than having a class not found exception somewhere at runtime, because we all know Java does lazy class loading. So at any point in time during the execution of your application, it might go look for a class that's not there, and it will just throw a class not found exception, breaking your application. With the modules, because we have these explicit dependencies, that's no longer an issue, because the module system can verify that the graph of modules necessary is actually valid in this case. So I hope this example illustrates some of the basics of the module system. There's much more to tell about this. You can also, for example, layer services on top of this mechanism to do like inversion of control and get a more decoupled setup even than this. We won't go into this in this talk. So if you're interested in that, I have lots of other content that expounds on that. But this should give you at least an overview of the basics of this feature in Java. Now, you might be wondering, okay, it's great that they added this in Java 9. And before we move on, I also want to make absolutely clear that using modules is completely optional if you're moving to Java 9 and beyond. So you can also still just use the class path and ignore all the module declarations, etc. But the whole point of adding this feature is to give us the ability to create large-scale maintainable code bases. And as it happens, the JDK itself is one of these large-scale and complex code bases. Right? Because they started development on Java in 1996, 1995, somewhere like that. It was the first release. And it's been developed for 20 years already. And it turned out that this big JDK was sort of the archetypical monolithic, big, complex code base. And it had all the issues you would expect of such a code base, right? There were some interesting dependencies, let's say, between parts of the JDK that actually shouldn't be there. And most importantly, lots of applications, but more so libraries, started depending on internal implementation classes that are in the JDK. And even though documentation, of course, states you should never use something in the com.sun package or the com.oracle packages, well, we're developers, right? We don't read documentation, first of all. And even if there is a warning, we just ignore it. So in practice, people started using these internal implementation classes of the JDK. Now, of course, the JDK team could have said, well, tough luck. If you do that and we change something, too bad for you. Your application or your library just breaks. But of course, we also know that Java is really, really big on backward compatibility. So lots of times, the JDK team decided not to do this. They decided to also preserve these private implementation classes so that they wouldn't break many libraries and applications. But of course, you can imagine that this is something that you can't keep up forever. Because at some point, you want to clean up, you want to refactor, you want to improve your code base, you want to extend your code base. And it was really hard to do. So this is one of the reasons why they actually looked into developing the module system and also used the module system that we just saw, not just to offer to developers, but also to modularize the JDK. And here you can see a small subset of the JDK modules that are actually in the JDK as of Java 9. So the JDK itself also has been chopped up into modules, where each module has a module declaration containing these explicit relations, these explicit dependencies, and also exporting only the public APIs and strongly encapsulating the private implementation details, just to prevent new code from being dependent on these implementation details. So in the end, this gives the JDK the possibility to evolve for 20 more years rather than grinding to a halt because of all these dependencies on internal implementation details and all the internal complexities of the JDK becoming too much. So as you can see in this graph, the JDK is nicely chopped up into many modules with real clear responsibilities. There's a Java XML module, Java logging, Java SQL. It's perfectly clear what is inside of these modules and what they do, and also what the relations between these modules are. And this is something that's, of course, not just valuable for the JDK, but can be valuable for any application, right? So viewed this way, a module system is a perfect mechanism to what I would say is to decrease the model code gap, where the model is of what you draw on the whiteboard together when you start a project, right? You have these nice arrows and boxes and everything's nice. But in practice, when you translate this into actual code, it might work for a while, but then the team changes, the architect changes, people take shortcuts, and everything tends to be more and more entangled. And the nice drawing that you designed, that you had as an architecture, actually fades away and things become more complex all the time. So a module system can help you enforce boundaries and enforce these relations and visualize these relations between components in your system. So that's how you should view the module system for the most part. But it's not just about helping you do things in a better way. It actually also makes things possible that weren't possible before with Java. And for that, I want to talk a little bit about a tool called the JLink, which is also included with JDK 9 and later. So JLink tries to address the issue that is this, where if you typically distribute your Java application, you would have to have a JDK, and on top of that, you run and you distribute your application and its dependencies. And typically, even though your application probably has more than 2 dependencies, but typically the application and dependencies are much smaller than a full JDK. And what's more important, your application probably doesn't use everything that's in the JDK, right? If we build a web application, it's very likely that it doesn't use any of the JavaFX or swing types. Probably, hopefully, nobody uses Cobra anymore, for example, but it's still there in the JDK, right? So JLink offers a way out. And what JLink can do is it can generate a so-called custom runtime image for your application. And what it does, it uses these module declarations. So this applies to modular Java applications. It uses these module declarations to find out the minimal subset of modules that include your application modules, of course, and your dependencies, but also just the minimal subset of JDK modules that your application needs. And it can notice, well, because you are in your module declaration explicit about what dependencies you have. So it will create a small custom runtime image, including these modules, but also including the JVM itself and everything that's necessary to run your application. And you can use this as a basis to distribute your application. For example, if you're in the sort of cloud space as a Docker image, or maybe if you're in the IoT space where every resource counts as well, then this is also a really interesting approach to doing distribution of Java applications. Again, this is optional. You can choose not to use JLink, but it's a new way of creating distributions for your Java application. Interestingly, this is also sort of a new phase in development, right? In between compilation and runtime. You now also have link time in Java if you want to. And at this link time, all code for your application comes together. And at this point, you can really apply interesting optimizations at link time across this whole code base. And this is actually implemented in JLink. So there are several optimizations that cross class and module boundaries that are implemented in JLink that are applied to this custom runtime image that is output by JLink. And even though it's just the beginnings, I really think that JLink will be extended with more and more of these optimizations because it's just such an interesting time, right? Just after compile time and before the runtime just-in-time compiler kicks in, you have lots of opportunities to do whole program optimizations. So that's about using modules and how modules work. Like I said, modules are completely optional. So the most likely scenario when you move from Java 8 to a newer version is that you at least initially still use the class path. And interestingly, this still has some impact on you, the whole module stuff that I talked about. And that's because, well, the JDK is still modularized, even though your application may not be, and your application may still be on the class path. So what happens is that if you have an application that uses some of these internal APIs or has dependencies that uses some of these internal APIs, when you move this from the Java 8 class path to the Java 11 class path, it will still run. However, it may generate runtime warnings when these types are accessed. So the JDK actually at runtime produces these warnings, which is pretty rare if you think about it. That really didn't happen before. So it's actually a warning sign that this is something that in the future will most likely be disabled. So you need to fix this. And if you're actually trying to compile new code on newer versions of Java that use these internal APIs, then what used to be a warning now is an error. So you absolutely are not allowed to use these types anymore, which is good. Another thing that you might run into is that some of the enterprise APIs that were part of Java SE, like JaxB, Cobra, JaxWS, these are like sort of a historical accident, how they ended up in Java SE. So what happened is that when they modularized the JDK, they actually put all of these technologies into their own modules. and immediately deprecated them in Java 9. And as of Java 11, which was released September last year, these modules have also been removed. So if your application depends on these technologies being there in the JDK, then they won't run out of the box anymore. Of course, the fix is quite easy. Just add an external dependency to these technologies, and they're all published by Java EE, or what's now called Jakarta EE. So that will be the way forward if your application depends on any of these APIs. And like I said, I hope nobody uses Corba anymore, but the other ones, well, they're pretty widely used. So there are alternatives to that in Maven Central, pushed by Java EE and Jakarta EE. But of course, modules is not just the only thing that's in there. I also want to talk a little bit about JShell, which is a interactive Java REPL. So who knows what REPL stands for? Anyone? Yeah, go ahead. Exactly. So read, evaluate, print loop. So if you didn't know this acronym, it probably doesn't mean anything to you still. So what it means is that it's an interactive console where you can just type in some Java code, you can hit enter, it will evaluate this code, meaning the code is run, and then immediately you will see the results of this code. And you can do this in an incremental and iterative way. And rather than just talking about it, let's just have a look at what it does. So here we go. I'm going to start JShell. There we go. And the first thing I'm going to show you is how to get out, right? Because we probably all had the Vim experience where you just launch something and you don't know how to get out. Here there's the /exit command. Okay, that was useful, but not very exciting. So let's get back into JShell. And the interesting thing is that we can just start typing Java expressions and Java statements now. So the simplest possible expression, of course, is sort of like this. And it works. It's 2. Luckily, that's still true. And you can also see this $1, which is a generated variable name. So now the variable $1 holds the value 2, which we can reuse if we want to, like this. Sorry, it should be $1, of course. Yeah, which is now 3. So this works, but it's hardly exciting. And you would want to use JShell for something more Java specific. So I don't know if you do a lot of bit shifting. Well, I don't. But if you do, this would be a very nice environment to try it out. Anyone wants to take a guess? So 4, left shift 9, 3, 2, 1. No? Okay, so 2048. Things like that are really, really handy to just check it out in an interactive console. Now you can also just do statements rather than expressions. So we can do system.println. There we go. Hello, Riga. And as you can see, it just does its work. Although there's no variable now because it's a void method, so there's no return value. Anyone else see anything different, by the way, with normal Java code? I did it here. There's no semicolon. Woohoo! Yeah, big difference. But anyway, if you have single line statements, you can omit the semicolon. There's also tab completion. So I do thread.sl, I hit tab, and I get sleep because that's the only one left. And then actually when I hit tab again, I get all the overloads that are there. So apparently there are 2 overloads of thread.sleep. And it says press tab again to see documentation. So let's do that. And we actually get the Java doc of thread.sleep, which is pretty interesting, right? Because we have everything together here. We have the ability to write code, get some completion, execute it, and also inspect the Java doc, which makes it a great interactive environment to explore new APIs and to try things out. So what if, for example, you would do this? This just works. Anyone else see something that's different with normal Java code here? No class definition. That's not really what it meant. There's no checked. You don't have to catch the exception here. So that's also handled by JShell at the top level for you. If by any accident you hog the foreground thread for too long, you just hit Ctrl+C and you get back your shell, fortunately. So yeah, like I said, this is a great way to prototype things, to explore things. I also use it, for example, to try out like regular expressions, because we all know that the syntax is slightly different in Java than in all the online tools that you can use. So this is a really nice way to do that. I use it often to prototype like stream pipelines and tweak it here and there and see what it does, if it does what I expect that it does. But if you're new to Java 9 through 12, so to say, it's also a great way to explore some of the new methods and APIs that are there. For example, there's a repeat method now on the string. So I can do actually like the Batman theme in just a single line. Isn't that awesome? Yeah. There we go. So just as an exploration tool, if you're moving to a new version of Java, is great as well. You can even do class definitions. You can create methods. You can do all kinds of interesting stuff. But for now, we'll leave it at this because we have some different stuff to talk about as well in other versions of Java. This is, by the way, still Java 9 that I'm showing now. Another addition are the collection factory methods. So if you want to have a predefined collection of items, then usually you would have something like this, right? So you have to think about, okay, what list am I actually instantiating? And 99% of the time, people just pick array list because, well, that's what everybody does. And then you have like add. This works, but it's hardly nice to look at. And many other languages have like syntax to create collections directly, and we're stuck with this. Okay, there's arrays.asList, but I mean, really, you have to use an arrays class to create a list? That's weird. And it's just for lists, not for sets and maps, etc. So fortunately, in Java 9 and later, we get these collection factory methods. What you have, in this case, list of, you just pass in all the elements that you want to have, and you get back a list without having to think about what actual type you need there and what you need to instantiate. These lists are also immutable, which is great, because that's probably what you want for these predefined collections. And it doesn't only work for lists, but it also works for sets and maps. Where in map, of course, you provide key value, like that. So while this is a very small addition, it's actually a very, very useful addition, and I use this a lot in my day-to-day code. Which brings us to Java 10 already, which is already more than a year old by now. And even though Java 10 had several features, I want to highlight one, which is a language change. And this was the introduction of var. And the official name of this feature is local variable type inference. But it's more well known by just how you use it, which is var. So it's about variables, of course, but not just any variables. It's about local variables inside of a method. And what var allows you to do is to, in case of this definition, to omit the type and to say var name is string. And people are going, is Java JavaScript now? Is it dynamic language? Ooh, what's happening? Well, just take it easy. No, it's still strongly typed. It's just that we asked the compiler to infer the type for us. So we don't have to type the type anymore. And in this case, of course, it's pretty clear that the type of name is string. So should you now go around and replace every type of a local variable in your code base with var? Well, please don't do that, because it's a feature that seems simple enough, but can have some pretty interesting side effects, and we'll have a look at that. But there are definitely cases where it makes sense to use var. Take, for example, this piece of code. You see URL is new URL. I mean, we're all guilty of writing code like this, right? And it's sort of repetitive. And there's buffered input stream is new buffered input stream. Again, lots of redundancy here. And we have this intermediate variable where we're not really interested in the type, but we just want to pass it along. So yes, in these cases, I do think that that using var makes sense. And the interesting thing that happens when you do this is that rather than the focus being on the types, the focus is actually on the names of the variables, which of course forces us as developers to come up with good variable names, which we always should do, but in this case, it's even more important. But in these scenarios, I do think that var has added value. On the other hand, there's also some surprising behavior, you might say, in var. So for that, I'm going to do some demo in our favorite new tool, JShell again. And I'm going to ask it to give us a little bit more feedback about what we're doing. And you, dear audience, are going to be my compilers for now. So let's start off easy. So let's say we have a var I is 1. What would be the type of I? Just shout it. Int, yeah. Awesome, you're great. Now let's up the stakes just a little bit. And let's say we have this. What will be the type of J? Double, I hear some floats. Actually, yes, you're all Java connoisseurs. This is double, but it might be better to do it like this, right? To be explicit about what you're actually meaning, rather than leaving it as an implicit. But what about, for example, this? What will be the type of K? Object, I hear something. Anyone else got another guess? it won't work. That's an option as well. There's also the type void with an uppercase V in Java, which has null as its only inhabitant. So that would also be a valid type in this case. But indeed, in this case, they decided to disallow this because, well, it could be object, of course, but that's rarely what you mean as a type. So it makes most sense to just not allow this. If you really want to do this, you need to be more explicit about what the actual type it is that you're intending to do here. So you could do it like this, or you could just say this will later be a string. So you can still use var if you want to, but it doesn't make that much sense, right? In that case, you just use an explicit type. But what about, for example, if we are going to use this newfangled factory feature, collection factory feature, and we're going to create a list containing an int and a double and a string. So what would be the type of this? Or would it be an error, or what do you think? List of objects, okay, anyone else want to take a guess? Array list of objects might be possible too. Error, okay, well, let's just see. No, it's this awful type, as you can see. So actually, in this case, the compiler is a little bit too smart for his own good. So what it tries to do is tries to find the most specific type that's in common between all these three elements. And object is common between all these three, but it's not the most specific one. It actually finds out that all of these types implement serializable, and they implement comparable, and they implement constable, and they implement constant desc. This is, of course, a type that you would never dream to think up yourself. You could not even express this type yourself in source code as a local variable type. So here, actually, you see things breaking down a little bit. And the lesson here just is only use var in combinations with the right-hand side, where it's just absolutely clear what the type will be. For example, when you use a constructor, it's completely clear, right? But in this case, it's just too implicit and too hard to reason about. Just one more to finish it off. So what about this one, where we say var array list is new array list, and we use this fancy feature called the diamond operator that was introduced in Java 7. So what would happen here? Would this be an error? Would this be something else? Or what do you think? What would be the type of this? Someone says error. Any other guesses? No, we think it's an error? Well, in this case, it's not. It's actually an array list of objects. Wow, right? So again, this interplay between features isn't ideal. And I would urge you to actually be explicit about the type here, or just not use var and use the diamond in combination with an explicit type. So I hope this illustrates that even though this seems like a simple and innocent feature, it's actually something that makes you think too much in some cases. So only use this where things are perfectly clear. Now, we're moving our way to newer versions of Java, and Java 11 has a completely new API to do HTTP calls. It replaces the awful API that is HTTP URL connection. Hopefully, you're not using that. Probably, if you're doing HTTP calls, you're using something like Apache HTTP client or OK HTTP, etc. Well, HTTP client now is a modern alternative right inside the Java standard library. And it supports HTTP2, it supports WebSockets, it has reactive streams integration, so it's a really nice and modern API that we now have in Java. So, three important types that you need to know about when using the HTTP client API is HTTP client itself, containing the send and send async method for doing blocking and synchronous calls, and non-blocking and asynchronous calls. All types in this API are constructed using the builder pattern. So there's a builder to create an HTTP client, and you get back an immutable and thread-safe HTTP client that you can reuse across your application. And of course, send wants an HTTP request. So that's the second type you should know about. And the request has everything that you would expect: URI, headers, the method, get, put, post, delete, etc. And then, of course, this also has a builder because you have the ability to construct this immutable HTTP request using this builder API. And where there's a request, of course, there's also a response. So that's the HTTP response type containing everything you would expect, the most important one often being the body. Now, the simplest possible way of using this new HTTP client API is shown here. So I create an HTTP client using new HTTP client, which is like a factory method, giving me back an HTTP client with all default settings. Then I create a request using the builder API, passing in a URI directly, in this case to https google.com. I configure it to be a GET request, which you could even omit because that's the default, but here I think it's pretty important to be explicit. And then you call build and you get back your request. And in the last line, you can see that I'm using HttpClient.send to send this request. And as a second parameter, I'm passing in a body handler. This is something that we didn't talk about yet, but a body handler is responsible for turning the raw response bys from the server into an actual Java object. So you can implement your own if you want to, but there are many predefined useful ones like this one, bodyhandlers.offString, which will help you to turn the response into a string. That's part of the HTTP response object, as you can see in the generic type parameter of HTTP response. So this way you can get back the response in any way you want using the body handler that you want to use for your use case. So all in all, a pretty nice, modern, easy-to-use API, which is a great addition and probably helps you to get rid of some external dependencies in your application when you move to a new version of Java. Which already brings us to Java 12, the most recent version released in March of this year. So in Java 12, what they actually did, they introduced something to help with this pattern of usage of switch statements. Because as you can see, I'm sort of trying to get the number of letters for a certain day, which is in an enum. And of course, I know there are shorter ways to do this, but it's just an illustration. And I begin with this uninitialized num letters in a variable. Then I switch on day. I have this awkward stacked multiple cases. And then I assign 6 to num letters for Monday, Friday, and Sunday. Of course, we shouldn't forget break, because, well, if you do, it matches, then it all falls all the way through and executes the other statements as well, which is weird, right? So all in all, this works, but it's far from pretty. So what they did in Java 12 is they introduced a new feature called switch expressions. This is a preview feature, so it's not final yet, but you can already use it if you have Java 12 and you use the enable preview flag on the compiler and on the runtime. So what you now can do in Java 12 is write it like this, which is much, much nicer, of course. As you can see, we assign the switch directly to our variable, meaning that the switch actually is an expression that returns a value. And rather than having this awkward stacked cases, we can have just simple case and then a comma-separated list of cases that should match. And once we have a match, we use the arrow rather than the colon, and the arrow is followed by just an expression rather than some statements and then break or not break if you forget it. So this is a really, really nice way to express this idiom that we saw before in a more clean and terse way. So like I said, this is a preview feature in Java 12. It will be finalized and added to the language for real in a later version of Java, which one isn't clear yet. But now's the time to start using this, playing around with it, and also provide feedback to the JDK team if you think there could be improvements still to this feature. So last, we're going to talk about adoption in the sense of, like we saw, most of you are still in Java 8. And you're not alone. Right? In 2018, there have been several polls that show that like 80% of the people are currently still on Java 8. And that's not just a single poll. JetBrains did one, 84%. Java Magazine also had a poll last year, same results. So as a community, by and large, we're still stuck on Java 8. But the interesting thing here is that Java 11 has been mentioned a lot. Even though we're already at Java 12. So why is that? Well, like I said, Java is moving to a 6-monthly release schedule. So if you look at OpenJDK as an open source project, there's a new release every 6 months. So this means that OpenJDK as an open source project also offers support and updates for these versions during 6 months. And if you want to move to another supported version, then you would have to move from Java 9 to 10, from 10 to 11, from 11 to 12, every 6 months. Now, of course, it sounds a bit scary, right? Going to a new major version of Java every 6 months. In practice, it's not that bad because, well, the differences are much smaller between 9 and 10 and 10 and 11 than they were between 7 and 8 and 6 and 7, etc. But even so, it's not always feasible to do this. If you're in a development team that's in complete control and where you, for example, just ship a Docker container, well, then it's easy enough. You can just upgrade Java when you want to. But if you're in an organization where there's like an ops department and you need to convince them to upgrade Java and you need to do that every 6 months, that might be harder. So in these cases, there's the long-term support. option. And LTS means that every 3 years a version of Java will be designated as long-term supported, so that you can stay on this for a longer time and get updates on this version. So Java 11 is the first long-term support version after Java 8, and after that there will be Java 17 as an LTS, but that's still a way out. Of course, there are trade-offs here, right? Because if you're moving from LTS to LTS, there's like 5 other releases of Java in between, where there can be deprecations, language changes, lots of changes can accumulate in these 3 years. So jumping from Java 11 to Java 17 will be probably a lot harder than just keeping up with Java and going to a new version every 6 months. So that's a deliberate decision that you should make as a team. Now, the important thing to know about LTS is that LTS is not something that is part of the open source OpenJDK project. LTS is something that's offered, in this case, by Oracle on Oracle JDK. And as of Java 11, Oracle JDK has become a paid option to use in production, rather than a free-to-use option in Oracle JDK 8 as we have now. So this has some effects. On the other hand, Oracle has also made sure that OpenJDK 11 and Oracle JDK 11 are feature for feature the same now. That was not the case in Java 8, right? Because Oracle JDK 8 had some more features and some better performance, etc., in certain areas than OpenJDK. That's no longer the case. So it's perfectly possible to just stick with OpenJDK and use that as a free alternative to Oracle JDK. In terms of features, there's no difference. In terms of support, there might be a difference. So if you're on Oracle JDK K8 currently, so you could move to Oracle JDK 11. That will cost you some money. It's actually not that bad if you look it up. It's pretty reasonable, but still you might not want to do that. And in that case, you'll probably look at OpenJDK 11. And like I said, fortunately, these two are now equivalent, and they will be going forward in newer versions of Java as well. But as I said previously, this LTS notion is something that's offered on Oracle JDK, on the paid version. And OpenJDK, like I said, in principle only gives and provides 6 months of support and security updates on each release. Now, luckily, the community has sort of rallied around JDK 11 as a LTS version from different vendors than Oracle as well. So there's, for example, Amazon Corretto, there's Adopt OpenJDK, Red Hat has an OpenJDK distribution, and they all offer long-term support on OpenJDK 11 as well, in addition to Oracle, doing it for Oracle JDK. So it's a pretty different landscape out there now. It's not just pick Oracle JDK by default, like it used to be. It's something that you need to think about. Which vendor are you going to select? Which JDK are you going to use? Are you actually going from LTS to LTS, or are you keeping up with the release train? Which sounds a bit intimidating, but I would definitely urge you to do that if you have the environment and possibility to do so. So there are lots of things to think about, and I hope I gave you enough food for thought with this session. And with that, I want to leave it at this. I want to thank you all for being here. It's been great being here in Riga. If you have any questions, feel free to come up. Of course, if you want to know more about the module system, I highly recommend going to this site and also checking out the book. There's much more content around what I talked about today at Pluralsight. If you don't have a subscription, I do have a free month for you of Pluralsight. Just come by and pick it up here. And with that, thank you all for being here and have a great day.